All right, this video is going to deal with proportional parts dealing with parallel lines. What the corollary says is that if we have three or more lines that intersect two transversals, are parallel if and only if they cut the transversals proportionally. So in this diagram, what's happening is we have these three parallel lines, line AE, BF, and CG. When this happens, when we have these parallel lines and we have these two different transversals over here, we're going to have proportional parts. Like when we talked about our triangles right here, it's just we don't have this vertex over here. Okay, we're cutting it off right here and we're adding another parallel line in. That's all we're doing. So we're still going to have proportional parts that are going to work exactly like this section right here with your triangle proportionality theorem. So again, I mentioned in that video that I love triangle proportionality theorem because most of the time you have your proportion staring right at you. Same thing's going to happen here. So discuss a little bit more in here. If line AE is parallel to line BF and is also parallel to line CG, then we're going to have proportional parts of AB to BC. And this will be equal to the ratio of EF to FG. So then you could just have your proportions there. Now another thing to talk about, let's work on a problem first. Sorry, getting ahead of myself. We have the frontage is the measurement of property's boundary that runs along the side of a particular feature such as a street, lake, ocean, or river. That won't be on your test. Okay. We want to find the ocean frontage for lot A to the nearest tenth of a yard. So we need to see this nearest tenth of a yard. So words, luckily they have this diagram. Here is lot A. We want to find the frontage is right here lining up with that ocean. So this right here is going to be our X, what we're looking for. So based on what we just talked about over here, again, your proportion is looking right at you. Here's what I call the proportional setup, fraction bar equals fraction bar. We're going to literally have here X over 60 is equal to, here's the other fraction bar, 58 over 42. In my last video, I showed how you can simplify 58 over 42 if you'd like to, so you have smaller numbers to deal with. I'm not going to do that on this one because a lot of people don't do that, and that's fine. So now we just have our proportional setup. Cross multiply, solve for X. Please pause the video and do this on your own. And let's make sure that we got 82.9 rounded to the nearest tenth of a yard. Now, what also ends up happening because of this, if three or more parallel lines cut off congruent segments on one transversal, let's pause there, look at this. Here's our three or more parallel lines. This transversal, the parallel lines are creating congruent parts. Segment AB being congruent to segment BC. That's what that first part says, that hypothesis. Okay, three or more parallel lines cut off congruent segments of one transversal. Then the conclusion is they're going to cut off congruent segments on every single other transversal, meaning we only have one more transversal, line EG over here. So since we see that these are congruent sections, automatically segment EF will be congruent to segment FG, making sure we put an additional congruency marking there. So, written out, we have if line AE is parallel to line BF, sorry for the sloppy handwriting, and is parallel to line CG, then segment AB will be congruent to segment BC as it shows here. And on the other side, segment EF will be congruent to segment FG. Note the symbols I'm putting above the letters. These are lines, these are segments. That's why the symbols have changed. Look at the diagram. Segment is just right here, the line is with the arrows. So we're going to go ahead and use both of these concepts that we just talked about. Number 3, we're going to find X and Y. Note that they have given you these parallel lines and they have told you that these segments are congruent. This is exactly like this problem. So that tells us automatically JK will be congruent to KL. So to solve for x, we need to use these two congruent parts right here. All we have to do when two things are congruent, their measurements are equal. This is something I say over and over again in my classes. So all we have to do is set this equal to each other. 6x minus 5 is equal to 4x plus 3. Please pause the video and solve this on your own. Please make sure you dig x equals 4. Now we take a look at solving for y. We're just going to use the other two congruent parts that are y, segment MP and segment PQ. So we would set 3y plus 8 equal to the 5y minus 7. You got it. Pause the video. Solve it on your own, please. Check that we got 7.5. All right, so when we take a look at B over here, we need to notice that B does not have any congruent markings at all. So we cannot set things equal to each other, like this one right here. So you have these have congruent, these have had congruent, these do not. So when they do not have the congruent markings, you have to go up to here and set up the proportion like we did on example 2. So with that being said, again, you have your proportion staring right at you. Here are your parallel markings. No congruent markings. So here with your fraction bar equals fraction bar, here, there's your first ratio, 7x minus 2 over 4x plus 3. We're going to have that equal to fraction bar 8 over 8. I'm going to simplify this down to 1 over 1. This is going to keep me from, this just happened to be that way. And this is keeping me from having to simplify. Now, another thing to notice here is because we have the 8 over 8, I just now realized this, but I'm showing you how also if you're not dealing with x's and y's like over here, you can use the proportions, so you can see it working both ways. Because we have these congruent, we know that these are going to be congruent as well, so you can set those equal to each other. I'm going to go ahead and continue with the proportion setup, and then I'll show you with setting those equal to each other, seeing that we should come up with the exact same thing. And the reason why here is because actually I don't even need to do that, because when I cross this out and give it 1 over 1 because the parts are congruent, we're cross multiplying 1. And 1 times anything is itself. So when we cross multiply this, we get 7x minus 2, and that will equal 4x plus 3. I'm actually glad I just realized this, and I'm showing you this because in retrospect, I should be explaining why we end up just having to set them equal to each other, and this is why, because this ratio will come down to a 1 over 1. So then we have these set equal. Go ahead, pause the video, solve on your own. Because the denominator comes out to be 3, it's going to be a repeating decimal. So I'm just going to leave it as 5 over 3, and you can just leave it as that, as the fraction, okay? So there is your proportional parts with your parallel lines. Whether you're given that parts are congruent, you can set them equal to each other. If they are not, we just set up our ratios, again, just like we did with these guys right here. All right?